Hello my lovely students, welcome once again to Dr. Saurav Sir's classes. Today we will continue again with group theory. Yeah, we were going ahead and doing some theory part on group theory. Okay, group theory, and I have also given you few mathematical examples in group theory. Right, now moving on to the next part of group theory. Alright, what does it say? Let's go ahead and read this and understand. Examples of group. It says examples of group over fields. In the previous video we had learned about fields. What is a field? I had given you the definition, very vague definition, but we will understand further on what is a field and how we can understand it. Okay, how we can solve it mathematically. Definition makes no sense because definition is just like history. Okay, everything is related to mathematics, whether group theory or anything. The mathematics is the main part. All right, so moving on to the first part, what does it say? The example, it says the set of all n cross n matrix over field with determinant non-zero. I know all of you all know how to find the determinant of an n cross n matrix. Yeah, if you have an n cross n matrix, say A1 1, first row first column, first row second, A1 2, A1 3, and so on, it will continue. Okay, this way also it will continue. So write on to n cross n matrix. Okay, the n cross n matrix over a field with a non-zero determinant. If you have a set of n cross n matrices, means you have a set of many matrices, many are like this. This is the M1, M2 will be there, then M3 will be there, different type. If their determinant value is non-zero, then it forms a group under matrix multiplication, also named as general linear group. You might want to mark this as with your highlighter. You might want to mark this because many times you will see notations like this. This means what? It means general linear group. General linear group, GL, general linear group. Okay, of degree. So what are we saying? We are saying that a set of n cross n matrices over a field of determinant is non-zero. If the determinant is non-zero, then it forms a group under matrix multiplication. Also it is named as general linear group of degree n over field F. So this means general linear group. This means general linear group of degree n. Okay, over field F. Very important to understand these notations, students. Okay, example. Let's rub off the extra parts here. Okay, that's what it means, over. Okay, let's write that over properly. Over field F. Okay, now moving on, there are examples given to you like GL2 Z2. All right, so the degree is 2, and Z2 over Z2 is the integers with 2 elements only. GL5 with Z5, GLN cube. All right, moving on to our second part. What is the second part? The second part says that the set of all n cross n matrices having determinant equal to 1. All right, now the determinant value will come 1 over a field F forms a group under matrix multiplication called special linear group of degree n over field F, denoted by this, denoted by SLN of f, or SLN of f, where n is the degree and this f is the field. Yeah, very simple to understand. Okay, SLN of f, that is the simple linear group of degree n, and GLN of f is a general linear group of degree n over field f. Okay, moving on to the next part. It says some important definitions. These are a few important definitions that must be in your mind, okay, while you are solving questions. Okay, order of a group. The number of elements in a group is called the order of a group. What is the order of a group? It is the number of elements in a group is called the order of the group. If the number of elements of G is finite, then G is called a finite group, and if the number of elements is infinite, then that type of a group is called an infinite group. So number of elements finite in G, then G is a finite group. Okay, and if number of elements in G is infinite, then G is an infinite group. Infinite group. It's not right there, it's not fitting. Infinite group. Okay, now moving on to the second one, order of an element. What is the order of an element? Order of an element is R. Then order of element is written in this form: OA is equal to R if a to the power R is equal to E, where R is the least positive integer. With this property, you have to note, there is a note here. With this property, you get a note. What is the note? Let's read the note, what they have written. The note says that if no such least positive integer exists for an element A, then we say that A has an infinite order. Okay, so if no such positive integer exists, like if I write a to the power infinity, then what is that? That is infinity, right? So if I write that, isn't it, then what do I get? Am I getting any particular positive integer? No, I'm not getting any particular positive integer. Then we say that A has an infinite order. Okay, moving on to the next one. Exponents of a group. Let G be a finite group if K is largest among the order of all elements of G, then K is called a group. K is called the exponent of G. Okay, what does it mean? Exponent, it means that when there is an exponent of a group, let G be a finite group and K be any largest number among the others of the elements. K is a number which is the largest among all the elements. Okay, then K is called the exponent of G if there exists A that belongs to G such that O of A is equal to K. Order of A is K, and no element of G has order exceeding. Okay, that means no element of G will exceed K. Okay, no exceeding of K. Alright, and K is then what? K is then called the exponent of g. K is called the exponent of g. Alright, did you understand? So in this video, students, what did we go ahead and learn? We learned about examples of group over a field, how we can get a n into n matrix over a field with a determinant which is non-zero. Okay, then we learned how to denote general linear group over a field, okay, with a degree n. Then the set of n cross n matrix which has a determinant equal to 1 over a field F forms the group and the matrix multiplication. Then we have learned the notations of special linear groups of degree n over a field F. Alright. After that, we went on to some important definitions of the order of the group. We learned about order of the group, how we can get an exponent, how the value k, the exponent value, cannot be greater than any other value. Okay, then the order of that group is equal to k, and how k is called the exponent of the group. Okay, so today we learned till this much, and we will continue this in the next videos. So students, you keep taking as much help as possible from Saurabh's classes, because all the help that you'll be needing will be provided here at Saurabh's classes. Thank you for watching, students.